Okay, I believe we are live. Let me just double check on actual YouTube. Uh, okay, it's not letting me check. Um, what's a way to check this? Sorry about that.
No worries.
Okay, we are live. Okay, nice. So
All right, I got you.
apologies, people on YouTube watching this for the confusion. Let me share the link real quick here in the chat. And I might try to trim this afterwards to make it a bit smoother. Um, cool. So welcome everyone to this Summer of Protocols Salon. This week we have Dorian Taylor, who was one of our core researchers this summer. Dorian, you spent the summer thinking about retrofitting the web and how to introduce denser hypermedia on the internet and fix everything that is wrong with linking as it exists today. So this was definitely one of the more ambitious technical projects. Yeah, so you can start. I feel you have your
All right.
setup to walk us through it. So yeah, let's start with you, and then we'll move this to a
Yeah,
conversation gradually.
sure, absolutely. I timed this at just under 40 minutes. So just and of course, because I'm working on retrofitting the web, I'm doing my presentation on paper. A part of the reason for that is because I literally just got like the core of this damn thing working on Sunday afternoon. So I'm going to be if I'm going to be doing any demos, they're going to be incredibly technical and they're going to be at the very end. So I'm just going to go into my spiel. So, um, if I was put on the spot and expected to summarize in one sentence what I've been working on all this time, I'd say it's an engine for making websites. And this aligns, of course, a lot, but it's the kind of answer likely to satisfy most people, unless, of course, they ask me what I mean by engine. To which I answer, well, there's a lot of grunt work involved in making a website. So the engine is the thing that does all the work that can be defined precisely enough to automate. So things like putting the navigation and header and footer on every page is a job for an engine. Plus, if you want to do anything with said website besides just look at the thing, e-commerce, blog comments, even as something as simple as a contact form, an engine handles that too. So by engine, we really do mean a compact, intricate machine in the middle of a body that gets you to go where you want to go. And there's plenty of engines out there. You've probably heard of WordPress and maybe Drupal. They're the finer grained frameworks like Rails and Django. They're the enterprise content management systems like SharePoint, Sitecore, Adobe Experience Manager. There's the newer cloud-based products like Squarespace and Webflow, and also Sanity, which is a new one, and plus probably hundreds that I didn't mention. So the natural next question is that given that there are all these engines for making websites, why make another one? And the glib answer that I'm trying to achieve is that I'm trying to achieve outcomes that I can't get otherwise. Because if I could, I would just use any one of the hundreds of products already on offer and not bother with this decades long odyssey. But the more thoughtful answer is a bit of an odyssey of its own. So my Summer of Protocols bio says that I was just the right age at just the right time. And I vacillated for a while about putting it in there before ultimately deciding that it was an important framing for where I'm coming from. Because I get thrown into the tech guy bucket because I've been at this stuff for so long that nobody I interact with knows to associate me with anything else. And the reality is that the first third of my life or so was decidedly low tech. I didn't grow up with computers like most people in my industry. Like most 80s kids, I played with a logo turtle once in kindergarten, messed with the Apple IIs in the school library, and mainly playing games like Fraction Muncher, and incurred, Oregon Trail, that kind of stuff too. And I incurred mandatory word processor and spreadsheet training in junior high. So I was like absolutely not interested in computers as a kid. What really got me motivated rather was making art and building things like actual physical objects. I remember very clearly at 15 thinking I would go into visual effects, kit bashing spaceships out of model parts and blowing them up, making monsters and aliens, that kind of thing. And what finally got me to take an interest in computers was in 1994 when a friend showed me that you could use computers to hang out and talk to people and get things. He was part of an underground art scene. Let me just get that up here. Where am I here now? Yeah, so he was part of an underground art scene that met on dial-up bulletin board systems, and to trade these things called art packs. So they were monthly releases. They were kind of like digital zines of ANSI art. Some of these are mine. I'm not going to say which ones. This mainly consisted of, as you can see, blocky pictures like you'd make in a DOS text editor. The style was overwhelmingly comic book art crossed with graffiti, and the subject matter was almost always advertisements for BBSs to call. The ANSI scene then overlapped heavily with the software piracy scene, which of course intersected with the hacker scene. And you would all hang out online and get together and meet space like graffiti meetups and raves. And this, by the way, is about the only thing from the movie Hackers that is an accurate historical depiction. The salient part here, though, is that you could trade your ANSI art with BBS operators for unlimited access to their files, which was pretty significant considering it took 15 minutes to download that which fits on a floppy disk, and most of them only had one phone line. So I thought this was a great deal. You make art and trade for access to tools to make more art. So the first thing I downloaded with my freshly earned Leech access, is what it was called, was a 3D modeling program. Instantly, all of my interest in kit bashing goes out the window. And aside from it being obvious that computer graphics was the direction VFX was going, why muddle around making silly little physical objects when you could make entire worlds in CG? The second thing I downloaded incidentally after convincing my mother to spend $600 on 16 megabytes of RAM was Photoshop. So yeah, the BBS art scene was my gateway drug into computers, and by mid-1995, the whole enterprise had moved onto the internet. All of this is a setup to talk about an era, more like a moment that happened between about 1997 and 2001. Prior to then, there really wasn't much you could do with the web as an expressive medium. You could make goofy GeoCities pages with recycled animated GIFs as early as 1995, but fine-grained control over the presentation that we're used to today didn't really come together until a few years later. As such, on the heels of the BBS art scene grew a nascent web design scene. I don't know if anybody remembers like looking at stuff like this. A lot of abstract 3D. So these were a lot of the same people, but not completely. The age group was the same, though, teenagers to early 20s, most in high school or university, the very tail end of Generation X. This detail, I think, is salient because nobody had a job yet, or at least certainly not a career. We had a lot of time to mess around with the medium and experiment. Moreover, while the BBS come internet art scene was certainly a globe spanning by this point, this was a much bigger, much more out in the open phenomenon. Instead of having to wait a month and download a pack of art to drool over, moreover, you could just click on a link and you could share them. And the work products we made were these intricate personal sites that stretched to every last affordance of the medium. There were these crazy little interactive art pieces, part trading card and part art installation. So this is a Prate Jamagura. She's got her stuff still up from 2001. This is a thing called Superbad by a guy named Ben Benjamin. It's still up after all this time too. It's got like all this nutty stuff you can click on. Here's one of mine from 99. Also 99, this thing. And also 99. I don't know if you can, this one's coming through here, but it kind of looks like an album cover and it throbs a bit. So I'm gonna just switch to this in a second. Let me just get myself here. So, like all the underground BBS scenes that preceded it, we were initially motivated by clout. There was an implicit ongoing contest to outdo each other just for the sake of seeing what we were capable of. Though our personal sites also eventually became our portfolios and there became actual stakes involved. And I know of quite a few people who got hired at companies like Razorfish or Sapient, I don't know if you remember those, off the strength of their personal sites. After all, being on the web, anybody could see them, and anybody included creative directors at design and advertising firms, video game publishers, startups, etc., which is good because we were all getting about be about the age where we needed jobs. As such, this little episode started to dissipate around 2001, in part because of the dot-com crash and also partially because it got professionalized, but also we were the ones professionalizing it. By 2001, I was starting to shift my focus away into the direction of back-end web development. And I taught myself to code back in 1996 for the express purpose of making generative art, like John Maida, then of the MIT Media Lab, and his students, Golan Levin, Ben Fry, and Casey Reese, who also went on to make processing. I'll just load that up here quickly. Oops, one SO. There we go. That should be it, right? So, Maida, he's got his iconic stuff like the Japanese and there's the absolute. Second here, let's load that up. This, I don't know. I'm sure we've probably seen this before. Anyway, so I had already had my first tech job doing support and system administration at a web hosting company, which I had left for my second tech job doing what I really wanted to do, which was visual design at a digital agency. The hosting company was great, by the way, getting paid to stay up all night and tinker and solve real problems in return for answering the occasional phone call. By the time I made it to the agency, though, it was clear that I could do just as good a job as the developers who were earning twice as much as me were doing, so that's the direction I ultimately went. There's not really much more to remark on the next 7 years or so, other than I carved out a niche for myself writing bespoke web infrastructure with a heavy lean toward information security. This is where the hacker connections came in handy. I also let my own web presence lapse around 2002 and didn't really think about it again for several years. So yeah, I didn't really think about my own website until early 2008 when I went solo. Incidentally, 2008, great year to go solo. But what had happened was that a couple of years prior, I had gotten bitten by the information architecture bug. And if you aren't familiar, information architecture is in the same family of practices as interaction design and content strategy, typically organized under the umbrella term UX design, which is a term you might actually have heard of. So I had first encountered IA, even done some at an agency job back in 2001, but having spent the preceding 7 years as an infrastructure developer, I had kind of a different take on it. Even these days, information architecture is synonymous with things like website navigation and product taxonomies, that is, categories and how to label them. Earlier progenitors of the concept, though, had a much more expansive vision for information architecture. For one, it wasn't relegated to websites or even computers. Information architecture in the early 2000s was about organizing and designing any information space, including libraries, museums, parks, and even airports. So, and when it was online, IA wasn't so narrowly defined as it was today. Again, this is about helping people orient themselves in an information space and find the things they're looking for. My own focus within information architecture, in a word, is comprehension. Another phrase used sometimes is situation awareness. And this roughly is the state of having a deep sense of understanding of all the things that are whizzing around you, all their dynamics, positions, and momenta, and therefore all the risks, opportunities, and directions a system can move. Now I can finally talk about a concrete problem I was trying to solve. Any organization, especially one that makes software that involves the internet, is mired in documents, standards, specs, API references, tutorials, policy manuals, best practices, and so on. Also, email, old school memos, and other internal communications, company directories, wikis, CRMs, and, which thankfully didn't exist at the time, Slack or Teams or Discord messages, Google Docs, and even more cloud-based sprawl like Figma and Miro. Also, other references like books and academic papers, even blog posts, news articles, and press releases. And then there's just data and its concomitant visualizations. So to understand what's going on within an organization, you need to read, and you need to read a lot. More specifically, though, you need to read a lot of fluff. A lot of the time is spent hunting for that one little factoid in the middle of a paragraph on page 47 of a 100-page PDF, 6 folders deep on a shared drive somewhere, the original long since misplaced. That is, not only do you have to wade through a lot of text, you have to spend a lot of time finding the text in order to wade through it. So in 2008, when I went to hang my shingle out as somebody who does consulting design on a business information infrastructure, I thought I'd generate some goodwill by creating a policy manual for the technique I had accrued using a sort of hypertext native rhetorical style that was kind of like a grown-up version of the stuff I was doing 10 years prior. It was like trying to make a resource where you could drop into any point, get just the information you need, and where you went from there was up to you. This did not go very well. The elaborate personal sites we were making in the dot-com era were characteristic in that they rarely scrolled. That is, anything there was to read would fit on one screen. And one screen at the time, I might add, might have been 1024 by 768 pixels, max. So to the extent that there ever was anything to read, yeah, you were never reading very much. And moreover, they were peppered with links and Easter eggs inviting you to explore them. And, you know, we can go back to Superbad here and, you know, click around on stuff and it's like weird, you know, things that are all over the place. And there's, you know, hidden things in here. So the problem with this, even though they were true hypertext artifacts, is that they didn't scale. These little dioramas might max out at a dozen pages, although I don't know about this guy. I think he probably piled them on over several months to years. But for my policy manual, without some kind of instrumenting infrastructure, I just couldn't keep track of what I was working on. I mean, clocked about 40 of these little bite-sized pages before kind of tapping out and going back to writing ordinary linear documents. And by that, I mean essays and reports and the like. And I even wrote at the time that about how the two dominant contemporaneous infrastructural paradigms, namely blogs and wikis, were inadequate. Blogs imposed a chronological structure that you didn't necessarily want. Wikis were notorious for enabling trailing off in the middle of the sentence or linking to things that didn't exist yet or ever, as it often turned out. Neither blogs nor wikis, moreover, provided the synoptic view needed to keep the content up to date and organize it into a coherent whole. This would be the realm of a component content management system, which is a concept that had been around for a while even then, but wouldn't gain currency until much later. And just a quick digression on what I mean by a component CMS. What is usually meant by a content management system is actually something more like file management system. And even today, the big enterprise products are still stuck in this paradigm. Component CMS is supposed to be able to address content not at the document level, but at the level of some arbitrarily finely sliced discrete semantic unit, like a paragraph or an inset. The intent for these components is they can be reused, and you can see all the contexts that reuse them. This enables you to shrink the footprint of content under maintenance, as well as help provide a more accurate and up-to-date material, leading to better outcomes for users. This is the theory, at least. Component CMSs, despite being talked about for decades, are extremely cutting edge. They only the most sophisticated players use them. Even still, though, these are arguably geared toward conventional websites rather than what I was trying to do. And anyway, it wasn't like you could get your hands on one of these things in 2008. The mechanism by which a component content management system actually connects its components together is a thing called transclusion. Learn to write, Dorian. And that is like being able to arbitrarily embed a piece of content within another piece of content, and then embed the same piece of content somewhere else in another piece of content. And transclusion is a term coined by a guy named Ted Nelson, who also invented the term hypertext all the way back in 1960. He's also a notoriously vociferous critic about how his ideas have been interpreted, and not entirely unreasonably so. Even over the 30 years in, and despite several proposals over the years to fix it, the web's idea of transclusion is a pitiful cartoon of what it could be. Now, for one, it isn't seamless. What this means is that in order to do transclusion properly, web engines have to roll their own way of addressing and dereferencing the components. And the problem with this is that the web already has both addressing and dereferencing mechanisms, the URL and HTTP respectively. So why go and invent new ones? This, in my opinion, is solving the wrong problem, but nevertheless, we see it everywhere. By inventing parallel mechanisms, you take an open system and turn it into an incompatible one. Instead of coming up with a software solution for your particular problem, consider outlining a set of conventions, a protocol, if you will, for how transclusions can be implemented irrespective of software product. So that way, different products can work together just like the rest of the web does. Fixing transclusion is a concrete step toward retrofitting the web with ideas from other hypermedia systems that were more sophisticated that preceded the web. A transclusion mechanism that uses open standards and operates at the network level, of which I had a naive version going back in 2008, but worked out for real in 2018, is a central consideration of intertwined learning. Closely related practical problem I encountered during this time back in 2008 when I was writing this policy manual is the fact that saving a file meant choosing a URL for it. Now, if you're writing like hypertext and you want to branch off into a tangential thought, you have to stop and think about what you're going to call that file. Unlike ordinary file names too, which are private, the names of URLs are public and therefore consequential. What I mean by this is when you expose a URL to the world, you lose control over it because things that you don't control, rather reference it. And if you change it, all of the links break. Now, since search engine optimization was a known practice by this point, the convention was to make the URL a derivation of the document's title. And this meant you had to come up with a title for the page before you even knew what you were going to write. Of course, if you change the URL, like I said, after you publish, then everything that links to the old URL is going to go to an error, at least not without some kind of infrastructure or policy around tracking renamed URLs. So the solution I came up with this was to assign a random identifier to every new URL, and this is not original, a lot of things do this, which would always be associated with it, and then overlay a human-friendly URL that once I had decided what that should be, and then have the system just remember everything, every URL that a particular resource has ever been called. This actually was one of the first conventions I adopted back in 2008. I was doing this by hand and just doing it in version control, but it became a key part of what is now Intertwingler a decade later. So stable URLs are actually a super important and critically underserved aspect of the web. In fact, if you wanted to do reliable transclusion, as I just described, at the network level, you would have to solve the problem of broken links. But even if you didn't care about transclusion, broken links just really suck. So it's a problem well worth solving in its own right. So I spent, I'm going to call this the Thecian Era, 2009 through 2019, making bespoke information infrastructure, which mainly took the form of internal tools and environments for data exploration. I had stepped away from mainstream tech, mainly due to a divergence in values and the feeling that I was spending years of my life working on things that would never see the light of day. During this interval, I was mainly working with nonprofit organizations. At the time, I jokingly compared working with me to buying one really nice tailored suit, which, you know, if you can buy the rest of your wardrobe from H&M is not an unreasonable thing to do. But a situation often comes up in this line of work when you want to generate a human readable web page out of a structured data object, so the page is the object. This is especially applicable to component scenarios like the one I just described, where you're using transclusion to compose different atoms into a larger molecule. And the way you do this even today is to create a bespoke piece of markup structure for every distinct view of every data object you're trying to render, and then knit those together, usually using some mechanism other than URLs and HTTP. This is silly, of course, because the data structure actually has a shape, and all it needs is a minimal set of rules that instruct a more generic renderer about things like what order to put all the bits and pieces in. This part of the puzzle was actually something I came up with all the way back in 2006. I had imagined a substrate that would handle all of the operations on a website that were the same no matter what the content was. The idea was that you could partition your work based on that which was context specific and that which wasn't. And the idea behind that is that the context agnostic stuff wouldn't have to change as often. Unfortunately, the surrounding tech wouldn't catch up until about 2011 or so, but a sizable chunk of Intertwingler is actually me finally realizing this substrate idea 17 years later. So in November of 2015, the researcher Brett Victor published a 12,000 word essay titled, "What Can a Technologist Do About Climate Change?" And it was packed with a lot of really interesting, actionable ideas. Of particular interest to me was a chapter he called Media for Understanding Situations, in which he discusses a concept he called model-driven debate. And I'm just going to zoom in here for a second. So I don't know if people have seen this, but his thesis was that any public policy debate that had a quantitative aspect to it, which is most of them, was doomed to gridlock in the conventional arena of op-ed and counter-op-ed, because either side of the argument could just pick the numbers they wanted and supported their respective position. So Victor posited that what was needed was a mathematical model that could be handed straight to the reader with knobs and dials that would enable them to ask the question, under what conditions is this policy prescription a good one or a bad one, and see the answer for themselves. He even demonstrates a candidate for what such a model would look like right on the page. So here it is right here. And you can move these around and you can get the rationale for why things are the way they are, and so on. So I don't know. I mean, I entreat you to play with it. It's really mind-blowing. So the issue that this idea raises, once again, is much like our bespoke.com era personal websites, is that it doesn't scale. This kind of thing is still at the level of a New York Times or Washington Post mega feature, or what in the business has come to be called a snowfall. You need a huge circulation to even consider it. And even then, you only have budget to instrument a tiny percentage of the total throughput of the outlet. Indeed, conventional news sites seem to be barely capable of linking the entities mentioned in their stories, let alone this level of instrumentation. What's more is that the models themselves are typically one-offs and aren't portable, so you can't reuse them in other works. As such, coming up with a regime in which it's cheap and easy to publish and promulgate computational models of this kind as part of public debate is something I find greatly important. So looking back on the, where am I at here? Looking back on the interval between 2008 and 2013, I probably did at least one graduate's degree worth of reading, which in fact, it was probably a mistake not to try to get credit for that. But this is around the time that I absorbed a pile of hypertext theory, a bunch of stuff on cybernetics, and nearly the entire bibliography of the architect, Christopher Alexander. At the intersection of all of this business was a guy named Horst Rittel, who had turned out to be a colleague of Alexander at Berkeley in the 1970s. And Rittel's contribution, aside from coining the term wicked problem, was a kind of planning game he invented called an issue-based information system. Where are we here? So the way it worked was that you would have people identify issues, which were simply states of affairs that you wanted to have something done about. And an issue would get responses in the form of a position, which was a prescription about a proposal, rather, for what to do about the issue they responded to. And then you would have an argument, rather, positions would in turn have arguments attached to them, which either supported or proposed the position. Now, issues, positions, and arguments themselves would generate, raise new issues, rather, that would in turn elicit new positions and new arguments, and then the cycle would repeat. So reading this after Alexander's PhD thesis called Notes on the Synthesis of Form sort of set off fireworks in my head, because the two were basically describing the same structure. Alexander's contribution was that, given the assumption that complex problems decompose recursively into aggregates of simple problems, if you had an interrelated network of issues, Rittel's term was issue, Alexander used the phrase fitness variable, you could compute the optimal decomposition pattern for a project based on its topological structure. In other words, this was the holy grail of project management. So I couldn't resist. I had to go and make one. Of course, 10 years later, I have a much more nuanced view of this whole business, but I still believe what I made was a good start. So 3 things came out of this experiment. The first was I ended up inventing a general purpose way to get structured data from a web browser to a server without having a lot of moving parts. The second was that this made it incredibly easy to bash out prototypes where what you were looking at was a wad of structured data connected to a bunch of other structured data. And the third was that this progress fairly quickly hit a wall when you wanted to vary the kinds of entities and relationships you wanted to represent without additional supporting infrastructure. And what I mean by this is that it didn't square with the incumbent paradigm of web development. There were way too many little bits and pieces connect to each other in way too many different ways. And so every time you wanted to add something new, it effectively doubled the amount of code. So I made this tool. This is the Issuebased tool about over the 2 weeks leading up to Halloween of 2013. So it's almost exactly 10 years old. And it has more or less languished for a decade. This visualization, the hyperbolic graph, is new, but everything else hasn't really been touched in 10 years. And this is really because any significant expansion entailed an explosive investment in programming. So Intertwingler is an attempt to make the development of tools like this actually manageable. And this remaking this thing is like the first thing on my list once I get the last little bit of the engine done. So going back to Ted Nelson, the godfather of hypertext, he is right with respect to the argument that hyperlinks that only go in one direction leave a lot of information on the table. We care about backlinks because when links only go forward, discovery tends to suck. Like you basically have to crawl the entire internet if you want to be able to know who links to you. This goes back to what I said earlier about situation awareness. So also in the policy manual I was trying to write in 2008, it was important for the reader to be able to go in the direction they wanted, because if I was going to force the reading order, I might as well have just written an ordinary document. So in Nelson's model of hypertext, you can see everything that links to whatever you're looking at. And let's leave aside for a moment the real issues we encounter with both network throughput and user interface when an entity has a crazy amount of backlinks. So if you store links as first-class objects, then a backlink is simply a forward link turned backwards. So just that. So if you don't store links as first-class objects, which is the case for most web development, your computing them is going to be potentially both expensive and inaccurate. You're not going to be able to do it in real time necessarily. So, but given that, one thing that Ted Nelson did not anticipate was the crossing administrative boundaries. And this is something that the web has been doing since day one. So here you have the very real problem of people lying to you about whether or not a resource they control or don't control, for that matter, links to something of yours. You can see this in, refer spam, for example. Like, the refer header is like almost completely useless these days, especially since you've got like no follow and no refer link relations. Pretty much the only thing I ever see these days in my referrers is spam. And if I want to know who's linking to me, I pretty much have to go to Google to and ask nicely for it. So we could imagine a universe where the trading of accurate and up-to-date list of cross-domain backlinks as a potentially viable target for a blockchain project. You actually trade. You could actually, your proof of work could be, the actual list itself and corroborating it. I don't know. You guys are the crypto wizards, but that's something that's sort of on my mind. But regardless, this is out of scope for now, because all I'm really trying to do is the user experience implications of backlinking within a website, plus whatever hand-curated list exists of known offsite references. But backlinks are nevertheless a key component of Intertwingler. You will notice when you have a lot of links, especially true of backlinks since they all concentrate at the same point, it's useful to concentrate to partition them based on what they are. And you can see this, especially in the Ibis tool, like the reason why you can identify the colors of both the nodes and the links is because they have been typed. And so when we're talking about a type system for links, and of course, it's also useful to be able to have a type system for the things at the either end of the links. And yeah, so you get differentiation pretty much for free. In this case, it's just CSS that's picking up the embedded metadata. So the technology, that does this has been around since the late 90s. It's called the semantic web. And despite being based on a set of simple principles, the semantic web is notoriously hard to work with, mainly because the tooling sucks, itself in turn because it's notoriously hard to work with. But the root cause of what makes the semantic web hard to work with, in my opinion, is that everything is a URL, which means you need a ridiculous amount of them. And it falls prey to the same problem I talked about several minutes ago. You can't create a new object or even talk about it until you decide what you're going to call it. Again, you take this problem away and the medium becomes a heck of a lot easier to work with. So in 2018, when I became let's load that up. I thought I was on the wrong one. So in 2018, when I began writing what eventually became Intertwingler, I referred to it as a breadboard for working out what I simply called good ideas for web content management. I intended for it to aggregate all the ideas I had developed in the preceding decade and beyond. My motivation at the time was to amalgamate some scripts I had been using to patch together my own personal site so I could use them to generate an extranet for a client. It has since grown into something that I envisioned, albeit dimly, all the way back to 2006, drawing on values and technique that date back even farther. And if there's one thing I've learned over the long arc of this project, is that a lot of information systems fail because they're too system-y. And by this I mean the solution the system typically proposes to manage information is to put all the information inside of it. And for starters, people resist this. They keep information outside of the system. And the control, and this is often because it would mean moving from a system they do control to a system that they don't. But the control doesn't need to be adversarial. I mean, think about the scenario where an employee keeps an authoritative copy of some information in a spreadsheet on their desktop because it's easier for them than dealing with the system. And so this kind of pattern is how the information that is in the system goes stale. And another situation that happens is that new needs arise that the system didn't anticipate. And what happens here is that people erect a different system in parallel before the original system can respond. Then they begin to depend on it, and now you have two systems that don't talk to each other. So an overarching principle of Intertwingler is to anticipate this kind of thing happening. Intertwingler can be a tiny thing that runs on your laptop, or eventually it can be a huge thing you pipe your entire enterprise through. I think if it not as a piece of software per se, but as a set of policies and protocols that are enforced by software. In that way, the current implementation is nothing but a demonstrator and is ultimately disposable. The real value is going to be in the description of a set of behaviors and expectations for interacting with other systems, even those other systems that can be retrofitted to interact with Intertwingler and even become more Intertwingler-like themselves. So I started talking about the web as an expressive medium, something that I believe has really languished over the last couple decades. Even myself, I never really made much art on the web. I was too busy making tools to make art. I kind of feel like a painter living thousands of years ago who had like an idea for a painting. So, planted a field of flax, harvested it and spun it for the canvas, chopped down a tree for the frame, killed a wild boar for the brush bristles, mined all the materials and did literal alchemy to them for the pigments, and so on. After all that work, it's easy to forget what you intended to paint. So my plan is, once I get this thing working in the next few days, is to spend some time tinkering with it. And with any luck, all of you will be able to tinker with it really soon too. Now, I want to take a minute just to thank the organizers of Summer of Protocols for giving me the opportunity not only to flesh out something that has been trickling along for over a decade, but really aim for the fences. So much so that I've been working on it solid since the program ended. One of the things SOP did that I didn't really anticipate was realign my expectations around what was already in the zeitgeist and what I was already going to have to explain. Yeah, this one pager came out of it. In particular, I want to thank Sarah for telling me within minutes of meeting me at the retreat that she had no idea what I was working on. And I also want to thank Olivia Steyer for getting me to realize that I had not one or two, but 5 distinct constituencies to think about when designing this thing. And of course, I want to thank Venkat for the name. So I regret somewhat that I had to choose between maybe finishing this thing by this afternoon and definitely writing a talk about it. So I only just, as I said earlier, I only just got the main part working last Sunday. So yeah, I can show you if you want. Without the transformation function stuff, it's not going to be very interesting to look at. If I don't step on any rakes, though, I'll probably have the whole thing working by the end of the week. So I can show you what I do have, or I can answer questions, or we can break for lunch.
I'm curious to see what you do have.
Yeah, same.
Sure. Let me get to. So, it's going to be real technical. Let me.
We can see the screen behind you, but we're like not crisp enough that we can read the actual code that's being printed.
Okay, I'm gonna crank it up.
Yeah. But I think there's like some weird rendering issue where like we can see. I think if you can just like briefly talk to what's on the command line, that'll be helpful because we can like roughly see, but it is like a bit blurry through the stream.
Sure.
So
Let me try to find another thing here.
Yeah, if you can increase the font size, that might do the trick.
Yeah, I'm gonna. Damn Emacs. You know what? I'm just going to load up another ANSI term. Okay. So for starters, around, I'm just trying to remember here. So I think it was around, like, it was probably the week before the retreat that we talked, then, Kat, about, I think it was sort of around then when I was like, I decided to really, really double down on like going super aggressive, ambitious with this thing. Because the original plan was like a lot more conservative. And one of the things that involved was this whole transformation infrastructure. And so what we're looking at right now, so the sort of theoretical underpinning behind that is that, like, suppose you have a resource, you'll have potentially another resource at a different URL that is a derivative of that resource. And so, like, say you have a PNG, but then you've got the JPEG, or you have the big image and then you have the small image, or you have, the HTML, or you've got the JSON. And so the idea is that to shrink the footprint of the set of things that are actually things that you have to care about and manage, and everything else is just an automatically generated derivation of that element. I ended up writing this entire infrastructure that enabled this. So this configuration that we're looking at, it's in RDF, effectively is a sort of hot configuration for the thing. So I went and I overhauled all of the the configuration infrastructure for this, I ended up making a where are we here? I ended up making an ontology for that. That's not it. So this is kind of the way to interface with this in general. This ontology is effectively what you're seeing over here, instantiated. So this took a while to work out. And it effectively describes the engine, it describes the handlers, it describes the transforms. This URN scheme enables the sort of hot configuration of like actual code modules. So when we fire it up, and I'm just going to load up another ANSI term here so that it's not, I don't know. Okay. And I can actually, and I'll make this bigger just a second here. How's that? So I'll just nuke the config here, and oops. Actually, I'll just go. There we go. It'll be in the command history here. Yeah. So this will go through the configuration. This is basically what will it be extremely slow? Yes, okay. So we go through the configuration. This is basically what the experience is like with, like, if you were going to download it. What? What is that? Okay. I'm like getting really clogged up here. Do you know what? This is probably something I've changed since I last run this.
Since we have 5 minutes left, I think this was decent taste. Maybe we should switch and do a few minutes of questions.
Sure.
Yeah, I'll kick us off. I think the 3 reference points I have for something like this is historically there's XSLT, and I know you're one of the few people who still champions XSLT. You've also got the recent notebooking revolution with things like Rome, which kind of do a version of graph database based into transclusion and stuff. And of course, the third one, since we are kind of in a crypto context, is things like IPFS. So can you kind of locate what you're building in relation to those 3 triangulation points?
Sure. So IPFS, I'll start with. One of the things that, so IPFS is a sort of, I mean, the F in IPFS is really sort of what we're, you know, what the focus is. It's effectively, it's a content addressable store. So all of the sort of opaque objects that, you know, are content addressable objects that I use. So anything that's like not a wad of RDF is going to go into a content addressable store. So it's conceivable at some point that you could hook up an IPFS backend, and so in Intertwingler the handlers are pluggable, and so it's entirely conceivable that you could just jack it in. The stuff like PKM, so the difference between like a PKM system and what I've got is, and you can kind of like get a sense of it with that IBIS tool, is that it's more like typed. So the typing of the objects, and the objects are also structured. So and the objects are typed, basically the resources are typed and the links are typed. Um, and so and what was the third thing?
XSLT.
XSLT. Yeah, so I'm still using XSLT, but like it doesn't really matter if you wanted to. And I know there's a guy, for example, who uses he sort of does this JavaScript bootstrapping thing with XSLT3 and yeah, so I still use it. I use it for the transclusion and I use it for like a client side basically just like painting on the like uh what's it called? Painting on the like presentation markup. I use it for that. Um, and so I sort of dispatch it based on the embedded metadata. So I use RDFA a lot. I use RDFA in the IBIS tool. I'm using RDFA, and it will the idea once I get the transformation infrastructure up and running is to transform into JSON LD and back. And so that is the managed Forney's really clever way to sort of smuggle RDF into the vanilla JSON using these things called context. So that's going to be a really interesting thing going forward. But like it's so the thing with XSLT and the reason why I sort of really stuck with it was to do with every element, every sort of chunk, every piece is complete. Like it's a complete document. It validates to the extent that validation is even a meaningful concept these days. And the idea with that is you could imagine like setting up like intertwingler as a kind of a daisy chain where you might have like this intertwinglers in Ruby, you might have one, written in Python in the future, or you might just have these like microservices that are standalone, and they sort of all will like one will have to be at the front, like one dispatcher will have to be or engine will have to be at the front, and it'll kind of like everything would plug into it. But you can imagine sort of like retrofitting like legacy CMSs, and all they will have to do is sort of conform, like just hit these checklists of sort of conformity, and even that you could probably cheat too by using filters. And so the idea again is really to shrink a bunch of the real sort of BS involved in generating very large numbers of very small objects to a point. So like that's kind of the angle with uh, uh, the PKM stuff. So like if you were going to make a PKM on top of intertwingler, which would once we're the transform stuff is done, that's going to be very easy to do. And I intend that's like really like one of the first things I kind of plan to do is and then again there's going to be these little tiny pieces and there's going to be a lot of them, and that's sort of like what it excels at. And really it's going to be interesting to see what you can do with that. And I mean you've seen this kind of stuff, like I mean you see it in Notion, like you see the transclusion happen in Notion, you see it happen in Rome, you see it happen in Obsidian. Again, it would be interesting to see types like link types and object types. And I mean, even if like the most basic thing that you were going to do was just change the CSS so that this one was pink and this one was green or whatever. This one was italic. This one has a little arrow because it's on another website or whatever. That kind of stuff. So like even just like that kind of level of differentiation would be really really useful. So there's that. I don't know what else you want to.
Yeah,
What
that's
else?
pretty much, yeah, that triangulates well with the 3 reference points I had in mind. But looks like we're a couple of minutes over, so you want to close out, Tim? Or yeah.
Yeah, I guess, is there another question on the Zoom? We can maybe take one more before we wrap up. Otherwise, we can close it out. If you have a question on the Zoom, speak up now. Okay, well, I guess we can close out then. Thank you very much, Dorian, for walking us through all that, a full history and then deep dive. And
Yeah, for sure.
yeah, yeah, and our next one of these will be, it won't be 2 weeks from now, but we will have David on December 13th at the same time. So another core researcher from this cohort to walk us through his work on standards and underwater cable connectors. Yeah, thanks everyone for tuning in, and we'll see you all December 13th.